My name is Michael and welcome to a new GTK tutorial. In this new GTK tutorial, or better say in this new GObject tutorial, we are going to learn something interesting, something new, so sit back and relax because the things are getting a little bit messy. But it is time to talk about the referencing, the object referencing and so on, and the things which you need to understand. For this, the functions which I'm going to introduce today, they are called GObject Floating, GObject Set Reference Sync, GObject Ref, and GObject Unref. What's the story of this function? We are going to check in a moment. But until then, I want to make some changes to my program. To our program, so I commented the call of the GTK widget hide, and instead we are going to call GTK Container Remove, GTK Container. And of course, from the grid we are going to remove the label, and then once that we remove it, we will put it back with a GTK Container Add function. I'm going to copy this part and throw it here. Basically, instead of hiding and showing, we are removing and put it back, or at least this is what we are trying to do in this video. Now let's see what happens. We have a button, we have a label. Once that we click the button, we are basically removing the object. If we click again, you see nothing happens. Well, why is that? It happens definitely not because of the GTK Container Add, but because of the GTK Container Remove. Now let's see what's the story with this container. GTK Container Remove, which is a function which comes from GTK Container, it is a function which says returns remove widget from container. Okay, we know that. Widget must be inside the container. We know that as well. The label, it is inside the grid. Note that container will own a reference to the widget, and that this may be the last reference held. So removing a widget from its container can destroy that widget. So if you want to use widget again, you need to add a reference to it before removing it from the container using the GObject Reference. Okay, so we have something. If you don't want to use the widget again, usually whatever GTK widget destroys, it is another story. Okay, so now we know that GTK Container Remove drop the reference count to 0 and destroy our object. So basically this is what happens. Now let us talk a little bit about something here. When you create an object like this, in this case the button, and or better said the label, at this point let's say which widget, the label widget which was created, its reference count is set to 1. I'm going to mark it here. Ref is equal to 1, but it is floating. We are not going to talk about what floating means now, but it is a flag which is between 0 and 1. Why is this? Well, 0 it means it is destroyed, or doesn't exist, and 1 means that someone used it. Floating means something like hello, I'm here, I'm ready to be used. So if someone wants to use me, then it should create a reference, or it should use a reference for me. Now I want to show you something. And for this, I'm going to introduce you the GObject Floating function, which I'm going to find it right here. It says check whether the object has a floating reference. Okay, so true if the object has a floating reference. Let us check if it's true and how it's working. So I'm going to call it right here before we call GTK widget show, basically after we call all these bunch of functions and so on, and see what happens. And the object which we are going to check it will be of course the label, and I'm going to say gprint the label has floating reference, else, because we need else so that we better understand, gprint there are no floating floating reference on the label, whatever. It is not important the text you are using. So let me compile it and run and see what happens. Well, there are no floating reference on the label. Whoa, why is that? I mean, I just told you, reference, it's equal to 1, but it is floating. But why is not floating? I mean, why the label has no floating reference? Which means the label is not floating, it has its reference count to set to 1. Okay, let us check a little bit the container again at the point where it says, note that the container will own a reference to widget and that this may be the last reference held. So it has a reference. Now, I'm not 100% sure, I need to admit it. You can let me a comment and correct me or help me with this. I'm not sure, but once that you basically call the GTK Container Add or GTK Grid Attach or something, basically these functions are changing the reference of the object from 1 floating to 1. So basically it's dropping its flag. So if I am right, I'm going to copy this part right here and drop it just after we create the label right here. You see, we create the label and then we check its floating flag. Let's see what happens. Well, it happened that the label has a floating reference, which is true. You see, it's working and it has a floating reference because we create it and has a reference of 1 with a floating flag set. And what's the story with the floating? We're not going to talk again about this today in this video. We are going to talk another day and another different videos. Anyway, now we know that GObject is floating, it's working, and the label, it is indeed its reference set to 1 and its flag is set to 0 to floating, sorry. Which means that if we call this function after we call the GTK grid, whatever, attach or later, because basically it happens after you call GTK grid attach right here. You see, it's changing its flag from floating reference to no floating reference. You see, there are no floating reference on the label, or the flag is not set, whatever. You see. Now I want to introduce you, I hope you understand it, because I want to introduce you the next function. So let me call it right here to be the label has floating. The next function which I'm going to introduce you now, it is called GObject Reference sync. Well, this name is a little bit creates a confusion, or again, maybe me, I'm the person which should understand it wrong, because to me sync means sync. You mean to drop it, you mean to put it down or something like this. I don't know, maybe I'm wrong. Anyway, the function, the GObject Ref sync says increase, you see, the reference count of the object, okay, and possibly removes the floating reference. Okay, so now we have a floating reference at this point because we created the label and we check it after we create the label. So it is true. If object has a yes, like I said, in other words, if the object is floating, then this call assumes over ownership of the floating reference, converting to a normal reference by clearing the floating flag. You see, the flag which I was talking about, the floating flag, it gets cleared. So basically, the label, the label reference, it is set now to 1 without floating, while leaving the reference count unchanged. So it doesn't count the reference. So this means if it is set to 1 with a floating flag on, if I'm allowed to say that, this means it will only set it off, that flag, and it will still be the 1. It will not be 2. But if the object is not floating, then this call adds a new normal reference, creating the reference count by 1. So basically what this function does, I'm going to call this function just after we create the label right here on the label. Okay, at this point what we are doing now, we are calling this function. If our label is floating point, which it is, now the reference is set now, it's equal to 1 without floating. Okay, because it's set to 1 without floating, we should now get the else part. There are no floating reference on the label. Let me see if I'm right. There are no floating reference on the label, which is true. You see? Now let me show you something. Let me comment the object ref sync for a second. Let me put this if call right here where we had it before, after we call the grid attach. At this point it will be the same theoretical. You see, we didn't change nothing. There is nothing which we change. Why? Because we are setting the reference of the label from floating to not floating, which is 1. Okay, at this point when we call this function, I'm not 100% sure what exactly happens here, if the reference still remains to 1 or it will be counted to another 1. I'm not sure. I think it's working only with its reference and it doesn't create a new one. Anyway, this is not important right now. What is important, it is that if I'm compiling the program again, you will see that has no floating. Yeah. Now watch, if you call this function, this one right here, after you call the GTK grid attach, where I'm thinking that the reference is changing, but I'm not sure it's set now to 2 or it was changed from 1 with the flag floating flag on to 1 with the floating flag off. But if this reference right here, it is now 1 on the label, this function here basically change the flag, the reference to 2. At this point we have 2 references without floating. So at this point there are no floating reference on the label, it will be called again. Yes, there are no, you see. So I'm not sure. I will need your help to make it this clear, if you get a reference of 2 or the reference is still equal to 1, because I'm not sure what's the story with the grid attach or with the GTK Container Add. If I go back to the GTK Container Add, it says only that adds a widget to container, typically used for simple container, For more complicated layouts, containers, okay. This function pre-parameter, so consider functions such as, okay. If those cases, the widget may be added to only one container at a time. You can place, okay, notice it. So we have no information. Because we have no information, let me see if I go to its properties, which is the child, can be used to we still have no information. So because the GTK Container Add doesn't speak something about the fact that the reference will be counted, it's saying only that it refers to a reference in its container remove right here. You see, it says note that container will own a reference to the widget. For me, I understand now that the reference which it's owned it is the reference which it gets it, not a new reference. Maybe it has a new reference, but I think it is the reference which you get it. So it, at this point, basically that reference which the GTK container gets, it is set to something which it get it. For example, the label, once that you pass it there and has the reference 1, it will drop to 0, the way how I understand. And if it's so, we will see. And if gets label drop to 0, then at that point basically we are destroying the label, and this is what happens to our program. We were destroying the label. Anyway, let me check a little bit the GTK grid. just to be sure if we get more information from the GTK grid attach, and only attach, nothing happens. So we have nothing about the reference. This is the important thing which I wanted to show you. Okay, so that being said, we know what's the story with GTK with GObject Reference sync and with the GObject is floating. Okay, now it is time to see what's the story with GObject Reference, because this is what we need, isn't it? For this, I'm going to click on the GObject Reference. Says increase the reference count of objects. So basically this means adds 1 to whatever value has the reference of the object in that point. I'm still not sure how exactly it does work when we call GObject Ref on a floating. Does that is going to be set to 1 and removes the flag like the sync does, or it increases to 1? No, I think that I'm right, and the GObject Ref, it will increase it to 2 at that point. So if I'm right, we will see. Now the GObject unref says decrease the reference count of the object. So when reference drops to 0, the object is finalized, and which means its memory it's freed. And if the pointer to the GObject may be reused in the future, for example, if an instance variable whatever, so it is recommended to clear the pointer to null rather than retain a dangling pointer to a potential invalid instance. So use GClearObject for this. Okay, we are possibly work with this one as well, but we are not interested about this right now. Okay, that being said, what we need to do, we need to call the GObject unref and the GObject reference. So unref will be here, which means we are dropping the label reference, and GObject reference will help us to increase the reference. What this means, the label before here, let me say the label has ref equal to 1. Now after this call, the ref will be equal to 2. Now we remove the program. Once that we remove the program, it drops the reference to 1. So now the ref, it is equal to 1. Because the reference of the label now it is equal to 1, basically we can call GTK Container Add label, and once that we call the label, then we can drop the reference which we hold it, and then later we can call it again the GObject reference to increase it again, and then to decrease, and so on. Let me see if I'm right. It should work, and there are no floating reference on the label, whatever. We are hiding it and we are showing it. See, it's working fine. Of course, it is printed now on the right side, and this we can fix it by calling the same function like I'm doing right now, the GTK grid attach with a 0 left 1 top instead of the traditional GTK Container Add. And now you won't see any different, which means that at this point it will look the same like before, but instead of showing and hiding the label, we are basically removing the label, and then we are add it back without destroying it. Because we don't want to destroy it, we need to call the GObject reference and count the reference, increase the reference to 1. In this case, because it was already 1 when we pass it, we were increasing it to 2. Once that we call the GTK Container Remove, this function drops the reference from 2 to 1, and because it's dropped to 1, we can safely call the GTK Grid Attach or GTK Container Add to put our label back because we have a reference on it. If we don't call the GObject reference on our label and we are not increasing its reference to 2, then the GTK Container Remove, you saw already, drops the reference from 1 to 0, and being basically dropped to 0, it will finalize, or how you spell it, whatever, the object, and the object is going to be destroyed. And once that it is destroyed, you cannot add it anymore. That being said, I hope you understand it, guys, because this was very important for you to understand these things. And once that you play a little bit more with this information, then basically you will understand it more better and much better than I do, which is very important and very, very interesting for us to work with. So that being said, thank you guys for watching. If you like it, please subscribe, share with your friends and neighbors, and until next time, see you guys.